So what I'm going to do is I'm just going to read in from the command line 2 arguments, and we'll print out the answer, and then we'll see if that matches. You know, as a human, we can do the max min a little more reliably perhaps than we can write assembly code. And so I'm going to use the operating system is going to, the OS and the compiler together are going to pass me the number of arguments that came in, and then all the arguments as strings. So I'm going to use the standard number of args trick, also known as argc, argv. Use standard terminology there. I want to be able to print some stuff, so we'll include standard I/O. I want to be able to call the function that translates a string to an int, which is in standard lib. That's A2I. I don't know if I'm going to need this, but just in case I do, I'm going to define assert. Case matters, so we can't leave that as it was. Okay. Now, so let's take, so this guy here is a function prototype, right? I can have it here, or I can have it here. If I put it here, that means I'm prototyping it only for inside this function. Now, I1, I'll give a default value of 10. I2, let's have a negative number to make it funky. Okay. So now, I'm going to see if there's any arguments. I don't check if it's greater than 0, because the 0th one is always the name of the routine, which won't help me here. Okay. If it is, I'm going to set I1 to the first argument. Okay, so far all I'm doing is I've got some default values. I'm reading in from the command line, but if the user has given me command line arguments, if there's at least one, I'll take I1 as the argument. If there's, okay, I need to change that a little bit. If I have more than one argument, then I can also set I2, right? So now I've gotten, either I can check them in with the default values by passing no arguments, or I can pass in any 2 numbers. And this is important because, for instance, you could write a max min that only works when you get the order correct, right? And so you want to be able to vary the order quickly. Is the reason I'm reading these in from command line. So now I'm going to make a call to. Okay. Make a function call inside the print statement for now. Any C questions before I go on? What I'm doing here? Yeah.
What is the A2I?
A2I is a function that takes a string and then it looks through that string, and if it finds digits, it translates those digits to an integer, essentially. And so, imagine that our string, in a second I'm going to type something like this. Let's say that I type, I'm going to compile the tester, and the executable, let's say, I call it xtst, okay, is the name. So I'm going to run it in a second, and let's say I pass 10 and 15 as my 2 numbers, right? What actually happens is this thing, which some of you may be doing, is actually what path to run out of. The path, this means the current path, right? Right in this directory. So just like // is the path above this, / is the path I'm in right now. In other words, the directory or the folder I'm in right now. Now here's the name of the routine to run. Now what's going to happen is when my function starts running, there's going to be, in this case I've passed 3 parameters, right? The name of the function is the first parameter, and then 2 command line arguments. The system will allocate and an array of strings. In this case, it's only going to be 3 long. Each string is really a pointer. This is why args here. So I've got this argument number of args. The shell that you're running, when you execute this command, it goes and it basically looks for spaces. And it says each space is a different command line argument, or the beginning of the program. And then it saves those values, because it doesn't know at this point. The system doesn't know what your program expects, whether it wants integers or strings, like maybe you want a person's name here, right? And so the most generic thing it can give you is a string. It can put anything in a string, and then you translate it using functions like A2I, okay? So what happens now is, this actually, the first element of the args array, so number of args will tell us how many there are. The shell will count, and it'll say number of args equal 3, okay? And then the first argument will point to a string that has in it, because that's what it was, the first word. And it stopped saying that was a word where it found space. And that's why if you want these two guys to be one argument, you have to put these around them. That tells the shell, even though they have a space in it, I want them to be one argument. Okay? But we didn't do that, so let's do that alone. Now our next pointer in that array will point to 10, and our final pointer is going to point to 15. Now the problem is, we want integers, but these are strings. And we don't want, for instance, the integer value of the first character, which we can get, right? We want this whole thing translated into the number 10 to the number 15. And that's what A2I does, is it simply looks through a string, like if the string had some spaces in it, it would skip it until it found a digit, and then it would translate all the digits it found there to an integer. Okay? So what I'm saying here is I'm first checking if number args is greater than 1. If it were only 1, that's the only argument I have. Then there's no data on the command line for me, right? If there is data on the command line, try to translate the first argument as a integer. And now, in my case, I'm not doing any error checking. A2I doesn't allow error checking. What happened if I passed in Bob here? Well, I'm going to get basically, you can think of it as not random, but it might as well be a random number, right? A2I is not going to function correctly. If you need error checking, you would use scanf, but don't worry about that. That's more of a C. It's obviously not going to be on our exams in assembly. And the only reason I'm explaining this is because y'all have seen it, and it might help you with reading some of my testers. Okay, so if I do have at least one argument aside from the name, translate that guy to an integer and assume it's correct. And if it's not, I'll know it when I print it out down here. That's why I'm printing out the values, so I know if something funky happened, right? And if I have more than just one command line argument, if I have 2, so again, there's one, the first one is the name, that's why I'm greater than 2 here, then set I2 to that. But in no way, by the way, have I allowed I1 and I2 not to have a value. That's why I gave them a default value, right? If the person gives me no arguments, I'm going to get 10 and negative 20. Right? Any more questions on that? Okay, so I'm going to print those guys out, and then, so that the compiler doesn't drive at us, it always has to return an integer, and I'll just return 0. Now, if I wanted to make this correct, I would check if it's the right answer, and I would return 0 if it was the right answer, and 1 if it were not, right? Anything non-zero means something went wrong. We don't have to worry about that here. Okay, so let's see if that worked. Always remember this guy. So what I'm doing so far, I'm invoking the compiler, GCC. I'm telling it I want the 32-bit AVI, even though I'm on a 64-bit machine. I'm telling it I want to name the executable something besides the default, which is usually on Linux a.out, which I don't particularly like. So I'm going to call it xtest. Now I'm going to give it what I want to compile. The thing I need to compile is the tester. That has the main. So the order of arguments is important. You put the main program first, is what you want to do. Now I'm going to fill out the rest of these guys, though in this case it would work probably with the bad order. Now, now here I'm doing multiple steps at once. What GCC is going to do for me is it'll take this guy, look at the .s and say that's sort of an assembly file. But it's got a capital .s, so it'll first run CPP on it for me. It'll spit that out in a temporary file. Then it'll create essentially a file with the same data in it, but .s, where all the CPP commands have been issued. In other words, all the C comments have been stripped out, all the pound defines, every place that's found I1, it's substituted in %EAX. Okay? And then it'll assemble that into an object file. Same thing over here. It's going to start out with a C file. It's going to compile that down to an assembly file, blah, 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 blah. Okay? Now link it. Now it's going to have two object files. It's going to link them. It's going to create an executable. It's going to link them with the system libraries. You need the system libraries to do things like printf, right? Because we didn't write printf. And then we give it the name we want to call it. Okay? So let's see if we get errors now. Okay, and by the way, we can make sure we get lots of errors. Turn on all warnings is what that means. Okay. So I've mistyped some stuff, obviously, in my tester. And maybe we wonder, is it the assembler or the compiler? So I can just do the same thing now, but instead of actually making executable, let me just compile only the tester. So we can see just those. Let me give them more space there. Okay, so I must have fumble-fingered the name of standard.io.h, right? I don't see it as .h there. So let's go look at our file. Indeed. Okay, so now it's compiling cleanly. So now I'm going to go back to the command that's going to do everything for me. Okay, so that's successful now. So I've now got an executable name called xtest that I can run. So let's run it with no arguments. Okay, so it worked the first time. 10 and negative 20 gives me that. So now let's run it with the reverse order to make sure it's working in both directions. So we had the minimum last time, so let's have the minimum first. 1 and 500. Okay, looks like we're working. Okay, any questions on all that thing? Right? And I won't go into this much detail in all the rest of the testers, but I just thought it might be help to see writing a very stupid one very quickly, right? And you don't have to, I sometimes give you a kind of a fancy one for the assignment, and you need a fancier one when we start doing vector operations, things like that, array operations. But for these kinds of things, if you're just getting the hang of things, you can do something quickly. So now let's go back. It's certainly true that we can write the same code a bunch of different ways. Okay. And let me explain, by the way, why I chose the one I did. I tried to, this is an optimization, this doesn't matter for the exam, right? Correctness matters for the exam. But there is a reason to do one or the over. The fastest thing you can do is when I1 already has the minimum. And so I wrote it so that when I1 does have the minimum, no branches are taken, because taken branches are slow. Okay? And so it's just an optimization that when it's already in there, and then basically if you knew it was written this way, when you called it, you usually have an idea of which thing is the minimum when you're doing it, or unless it's just a 50-50 chance, right? In which case you would put that one first, because that's going to be the fastest thing, right? And in that case I just did all fall through, I never take a branch, right? But okay, but we can reverse this, right? We could say, So we can do the reverse of this easy enough. Now, let me explain what I just did. I didn't want to actually have to use a comment because comments sometimes have trouble with containing comments. But CPP can include or not include whole sections of code with pound if. 0, of course, is false. So if false, do this. So I'm not doing that code anymore. If I were to compile this right now, it's just like that code did not exist. Right? And I'm going to rewrite that in a new implementation over here. But right now, it's just move, and then return. Right? And the fact that we've left this here would never matter because we would never go to that place. Right? There's no way to get to that code. Any questions on that? And I'll get rid of all this code to make it a little prettier, but I want to leave it up there while we wrote so I remember what the reverse of what I want to do is. So I can just reverse this and say, if I1 is less than or equal to I2, so which one did you do?
I did less than, but I mean less than.
Okay. Yeah. When it's equal, they're both equally correct, right? So you don't care either way in some senses. So you want to say if I1 is less than I2, go to I1 is max, right? So let me, I love the word max. Okay. So again, so I did less, so I'm going to use less, and it's about I1. So once again, I look at the order, right? So 1, it's going to be the less greater, it's in terms of I1, right? So if I1 is less than I2, then I1 is the max. And now, this means that for if I don't take that jump, so let me put the label here. Now, some of you, let me show you what some of you did, quite a few. So I'm going to get rid of this now since we don't. I mean, we could have left it in, but just to make it a little maybe easier to read, do this. Now, what some of you did was you would say something like, that, right? Now, that's obviously not doing anything. Because if you don't take a jump, you just do the next instruction, always. So jumping to the next instruction is useless. And some of you made it even worse. Taking an unnecessary jump was not enough performance loss for you. So you did a greater than or equal jump to nowhere when you jump to the next instruction, right? Now, all of these are correct, but they're not doing anything, right?
Where can we get access to the video? Have to go to the recording.
So I don't know. We're going to have to figure out if we'll see if we can post it on Moodle. I think we can post it up to 500 megabytes on Moodle. And if this is cutting it off into sections, we could probably section 1, section 2, section 3.
Okay,
We'll have to get with the camera person to get a copy myself. Yeah.
The return after the move I2, you wouldn't need that return movement.
So it depends on what we're going to do. So I haven't finished writing that guy yet to get this guy correct. So now I'm just going to get rid of this stuff that we agree we don't need. I just wanted to show it doesn't affect correctness, but it does make me confused when I read it like that. Okay. Now we have to do this because we need to set the return value to I2. We've determined I2 is actually the minimum, right? Down here, so I think your point is what we could do is this. So before we do that, let's do the simpler guy. this guy would be correct, right? Now we could put, so that it's clear to ourselves, right? But now EAX already means I2. I1, right? According to right here. Therefore, this is move EAX, this really means, which of course doesn't do anything, right? It just wastes time, so we wouldn't do that. And then, what someone pointed out, now all I'm doing is I'm jumping, I'm not actually doing anything with this label. I'm just jumping down to it and returning. So I could just right? So now what I'm doing is I'm saying, and to make this clear to myself, I can move this guy over a little bit. Because what I'm really doing is I'm saying, if L1 is the min, if I1 is the min, don't move I2 into the return value, and then return, right? Okay, so let's see. We got that, we got that. We got a label this time.
Yeah, I have one is under your
What's that?
your label for the return. It has to be I1.
What is that?
I2.
That
The label.
the return.
Oh, you're right. And we could change this to like is already min, right? We'll leave it like this. So now let's see if we can compile and test this guy. So now we need to do okay, so that works as well. Any questions on that? Okay, so now let's try so the idea behind this one is to actually learn a little bit. So we're going to use the same thing we just did, but we're going to extend it. We need to return two things, the max and the min. Okay? And because you only can make one thing the return value of the function, anything else you have to return, you have to return by an address. Right? Which is another way of saying you have to write the value to memory instead of being able to just write it to a register like we do when we make EAX work, right? And so, now, and then here's an implementation of what we're trying to do in C, right? We're going to write the function get min max. It's going to take the two parameters, integers just like before, but now we're going to return the minimum just like we were before, but we're going to use a pointer. And what is going to happen is the main function we're going to write, the tester, will allocate space of a local variable, and then it will pass us the address of its local variable. So what's going to happen is, if this is our picture, I'm going to need a new picture anyway. All right. Return address. So we got 3 parameters now. I1, so this is at 0, this is at 4. I2, that's at 8. And then we've got max pointer. And that's going to be at 12, because all of these guys are 4 bytes in size, right? Now, up above here, somewhere in this range, is the caller's stack frame, where he's storing all of his local variables that he needs. Well, the caller is going to allocate somewhere on his stack frame a variable called max or something like it. And the thing is, we don't know where in his stack frame he stuck it. So we can't directly go access it unless he gives us the address. And that's what a pointer is. A pointer is a way to pass an address to somebody so that instead of making only local changes, changes to their own piece of memory, they can directly write to arbitrary sections of memory. Okay? And so this is what it really means to do pass by address. You take an address that you know and you pass it to somebody else. Now since they know the address, they can read and write that address, which is called dereferencing the pointer, right? Because the pointer is a reference and you dereference it by getting the value that's it's pointing to, okay? So that what we're going to do is pass him this address, which might be, for instance, maybe at 20 ESP. But we don't know that until somebody tells us, right? And we'll see them. So what's going to happen is, whatever this address is, the value of max will not be written here. This address will be written here, right? So let's take the example that's not true, that our stack actually is at 0. Well, if that were true, that the actual address would be 20, so what's going to be written here is really the integer value 20. And then we could load that and operate it on it as an integer. Nothing, it's just bits, right? And assembly, everything is just bits. But we know that we're expecting by the call function, that's a pointer. So we're going to say, we're going to load that as an integer, but then we're going to translate it, we're going to use it as an address, because that's what we know it was. Even though if we just look at the bits, you can't tell by looking at the bits whether it's an integer or a float or an address or what it's used for, right? Typically.